taste what? Sour. Bases, their taste is bitter. Okay, so you can just imagine soap. Soap contains a lot of bases. If you accidentally tasted a base, then you will know the taste of base. Okay? There are some bases we can taste, like we can drink, which is milk of magnesia, your Tams tablet. Those are edible bases. Then if you touch acids, acids are super thin. It is like water, but bases are like thick consistency. They are slippery. Conduct electricity. So when it dissolves in water, both will conduct electricity because both will produce what? Ions. It need ions to conduct electricity. We know that one will produce positive and negative. Both will produce positive and negative ions. Okay. Then corrosivity. Corrosivity means reaction with the metals. Okay. So acids. Among acids, we learned an activity series. Remember, in that activity series, there is a hydrogen, then below copper, mercury, silver, and here potassium, sodium, calcium, aluminum, all those elements. Everything above hydrogen will react with the metals. So acids are, most of them are corrosive. That means they will react with the metals. We can never store acids in a metallic container. So reactive metals, okay, only reactive metals. Okay, bases, dilute bases are not, but strong bases are corrosive. Also, it doesn't include one thing called the caustic, but I want to talk about that. Bases and acid will react with our skin and they are caustic. But compared to acid, acid will immediately burn you, but bases will react with your skin and convert your fats into soap, I would say, or sodium salt of carbonate. So strong bases are really, really dangerous. Okay, so that's why we'll call bases are generally caustic. Then litmus paper, we have seen in the class, blue litmus paper will turn into what? Red. Acids can change blue litmus into red. You can make litmus paper at home if you have hibiscus flowers. Just get one hibiscus flower and rub that on in your paper and you can make blue litmus. And bases turn red litmus into blue. So the easy way, sometimes people will miss up those color. Acids are dangerous, so always end up in red color, you can remember. Phenolphthalein is an indicator usually used for in titration reactions. Okay, it will show different color in acid and base medium. Acids basically in phenolphthalein it will be colorless, or we can see when you do the experiment, you can see it will become a little bit cloudy, like a milky color. But phenolphthalein will become a hot pink. Okay. Another indicator is bromothymol blue. Base will form a blue color. Okay, bromothymol blue is a green color liquid. It will add into base, it will become blue, and acids will form yellow color. Ion produced, okay. We know that both will produce ions. Acid will produce what? H plus ions. and base will produce what? OH minus I. Then this is a donor of hydrogen, and this will be an acceptor of hydrogen. Okay. Also go ahead and write the acids will have pH lower than 7, bases pH higher than 7. We will study about pH in a minute. Then write the household examples, okay? So we can say acids, vinegar. Vinegar, that's a common name. Its name, you might know the acetic acid or ethanoic acid is the actual name. Acetic acid is a common name. Vinegar is the industrial name. Ethanoic acid, DIUPAC name. Okay, then soda. Soda is H2CO3. Then lemon juice, citric acid. Then lactic acid, you can see that is in yogurt. Butyric acid, which is present in some of fruits. Okay, then all cleaning supplies. Cleaning supplies are generally basic, like bleach, detergents, soaps, then baking soda. All of those are, there are so many examples. Okay, we will do a household lab, and we can see what are the examples for bases and acids. Okay. So those are the general physical property. Now look at the chemical property. Okay, chemical properties of acids, how they are reacting with the other compounds or elements. First one, reaction with the metals. We already learned that is called a single replacement reaction. We are deciding the reaction based on activity series. You will have a formula sheet with the activity series there. Acids react with metals, produce hydrogen gas. Metal will displace hydrogen, single replace hydrogen. But remember, hydrogen can only be replaced by metals that are more reactive than hydrogen or above hydrogen in the activity series. Okay, example, zinc. Zinc will react with hydrochloric acid, replace hydrogen and form zinc chloride. Since zinc has a charge 2, there are 2 chlorine needed, and since hydrogen is diatomic, there is 2 hydrogen needed, and we will balance the equation by writing 2. If you are treating aluminum with nitric acid, it will form, aluminum has a charge of 3, nitrate has 1, aluminum nitrate plus hydrogen. Okay, so 3, only need to write 6 and 3. So that's how we are balancing the equation. Okay, so now second reaction, which is reaction with carbonates or bicarbonates. Acids react with carbonates or bicarbonates, produce an ionic compound. Oh, I need to write carbonates here. Carbonates or bicarbonate. produce carbon dioxide, water, and ionic compound. We'll call all ionic compounds salt because they are salty. Okay, so this is a reaction. You might have seen the fire extinguishers, right? Okay, fire extinguishers will extinguish fire producing what acid, what gas there, carbon dioxide. So basic reaction happening there, they will have calcium carbonate or baking soda, any carbonates and one acid. When they react, it will form carbon dioxide, water and calcium bromide. It's kind of a double replacement followed by decomposition reaction. Okay, so this is the salt, and you know the formula for water and carbon dioxide, right? Okay, so then third reaction, that is called the neutralization reaction. Okay, that is topic 3. Neutralization, you know that acid have acidic property, bases have basic property. When they combine, they will form water. Okay, so neutralization reaction is double replacement reaction. It is a special type of, or one of the examples of double replacement reaction between acid and a base. So acids have, starting with hydrogen, bases are ending with OH, they will combine and form water, and the metal from base and non-metal from that form a ionic compound called salt. So neutralization produces water and a salt. Okay, I explained salt is produced when non-metal from the acid and the metal from the base combine. Water formed from hydrogen and OH from acids and base. Okay, so there are so many practices we had to do. I'll do for few questions, then rest you had to do and check the answers in class. Okay, let's go down right. Phosphoric acid formula is H3PO4 combined with aluminum. Aluminum has a group charge 3, so the 3 OH. Okay, we know that all double replacement reaction, the reactant will be in aqueous state. Even though it's not in aqueous state, this reaction will take place, but because the product is, one of the product is water. So what it is happening, this OH and this hydrogen. So you don't need to worry about, I know people always confuse, oh there are 3 hydrogen here, 3 HO, then they will go change the formula into H3O or something like that. No, always the product is water. You have to balance the equation, okay? Then aluminum is the metal, okay, and PO4. So aluminum is the metal and PO4 both has charge 3. So 3 plus and 3 minus, we need only 1. Okay, and water is a liquid and aluminum phosphate is a solid, so we know that it will form a precipitate. Okay, now we have to balance the equation. Okay, there is 3 plus 3, 6 hydrogen, so I'm going to write there is 3 H2O there to balance the equation. Okay, same thing, hydrogen chloride and NaOH, you will get NaCl and H2O. Okay, and I'm going to label this. Okay, this is acid, base, salt and water. Okay, acid, base, salt. Okay, this is the actual salt we are eating. Okay, sodium chloride. Okay, so you can do the rest. I will do